So, radical equations and problem solving. So, we're going to be taking our radical equations and we're going to be solving for the variable now. So, we're going to be working in one variable. We're using the power rule. Power rule states that if both sides of an equation are raised to the same power, we are creating a new equation. However, the solutions to the original equation are contained within the solutions of the new equation. Okay? So, for example, I raise it to a power, I solve that equation, and I get 2 answers. Okay? Or 3, or 5, or whatever. The answers that would solve the original equation will be included in that list if there is a solution. Sometimes there's not a solution. Okay? But if there is a solution, it would be contained in the list of the new equation after we raise the power. If we have extra answers, any of the solutions in the new equation that are not a solution to the original one are called extraneous. Okay? So if I get 3 answers and only one of them works, the other 2 are extraneous. If I get 2 answers and only one of them works, the other one is extraneous. If I get 1 answer and it still doesn't work, it's still going to be extraneous. So any of the solutions that we find from the new equation that don't work with the original one are going to be extraneous. Our process is pretty straightforward. Our first step is to make sure that our radical is isolated on one side of the equal sign. It needs to be by itself. No coefficients, no constants. There can be whatever we want inside the radical for the radicand. That can be as complex as it needs to be. But everything outside the radical has to be on the other side of the equal sign. Okay, step 1 is isolate. Step 2 is raise. We're going to raise both sides to a power equal to the index. So if I have a square root, what exponent am I going to use? 2. If I have a cube root, what exponent am I going to use? 3. If I have a 6th root, what exponent am I going to use? 6. Okay, matches up. Because we need to be able to cancel those out. Okay? Now, if the equation still contains a radical term, we have to repeat step 1 and 2. We're not going to go that far in the standard course. And then we're just going to solve the equation as we would any other standard algebraic equation. We're going to end up with either a linear equation or a quadratic equation. We will solve those, and then last but not least, we have to check all proposed solutions. This step is not optional because we will occasionally get answers that don't work. So we have to check our solutions to figure out which ones do and do not work with the original equation. So to start out, I have to isolate. Is my radical by itself on one side of the equal sign? Yeah, I don't have anything else outside of this on the left side of the equal sign. So step 1's done. It's isolated. Step 2 is now to raise to the power. Okay, so what is the index on the square root? 2. So what power am I going to raise it? 2. So both sides of the equation are going to get raised to the second power. So, what is the square of the square root of x minus 1? I'm sorry, the square root of 2x minus 1. 2x minus 1. And what is 5 squared? So now I just have a linear equation that I can solve like we've been solving linear equations. Feels like forever now. What am I going to do first? Add the 1. Good. So add the 1 to both sides, giving me 2x equals 26. And then x equals 13. Okay? So now we need to check. So I need to take 13 and I need to plug it back in for x. Okay? What's 2 times 13? What's 26 minus 1? Does the square root of 25 equal 5? Yeah. Okay? Most of the time it's going to work out. But we still have to check. Now luckily there'll be some patterns that you can hopefully eventually recognize for when we're more likely to have extraneous solutions than not. There's certain types of equations, and when you can recognize those certain traits, then it will make the process easier and give you more confidence when checking your answer for the likelihood of one or more of them being extraneous. Okay? Step one is to do what?
To remove the negative.
And we want to isolate it. Yeah. So since my radical is not isolated, I need to remove any constants or coefficients to the other side, leaving me with the square root of x minus 1 equals 1. Step 2. Square it. Now what? Alright. Now what? Plug it into check. Square root 2 minus 1 minus 1. What's 2 minus 1? What's the square root of 1? Does 1 minus 1 equal 0? So we're good.
Other side, other side.
Why don't you write that down later? So that way you can focus on this one. 2 minus 1, 1. Square root of 1 is 1. 1 minus 1 is 0. Alright. Step 1. Isolate. So, is it isolated? No. So, what do I do to get rid of 2x to the other side? Subtract it. I'm moving the whole term. If I was moving just the coefficient, I would divide. I want to move the entire term, so I will subtract. The square root of x plus 1 equals, what's the right side of my equation? Okay, or negative 2x minus or plus 8 if we want it in standard position. Either one's fine. Alright, step 2. And you square it. And you get rid of that radical. Second power. Okay, and square both sides. So I get x plus 1. Then how do I square negative 2x plus 8? Write it twice. Okay. So x plus 1 equals 4x squared minus 16x plus, nope, sorry, not plus, minus 16x again, plus 64. Now what? So what's negative 16x minus 16x? 2x. Say again? Add 32 to what? So I can subtract x, is that what you're saying? Let's get everything to one side so that we can solve the quadratic. I don't want to move it this way, I want to move it that way.
wait, don't you simplify it? Don't you like find the or something? Don't you factor? Yeah. Whatever multiplies to 4 and 63.
Yep. So go ahead and multiply your 4 and 63. What is 4 times 63?
252.
So I need something that gives me a product of, what'd you say,
252.
252? But a sum, negative 33.
Second. Product of 252.
Negative 12 times negative 21 equals 212 plus negative 21. Negative 11. So now I can take my negative 33 and split it into those two things. This is our factor by grouping method. No, that just takes us back to the negative 33. Factor by grouping. So what am I going to do next? Group what?
4 minus 12x.
Yep.
The negative 21x.
There you go. So what am I going to do with the 4x squared minus 12x?
Would it be 4x and it's x minus 3?
Yeah. And then the next one? Remember, I want to factor something out of these that leaves me with x minus 3 in the parentheses.
21.
Close.
Negative.
Negative 21. Negative 21 will leave me with x minus 3. So my two factors are
X minus
4x minus.
no. See how it says continue
This is
right
so
here?
mean.
That means we've got more.
So long.
Why?
Would you prefer I not do an example like this?
I would prefer that they did this.
Well, too bad.
Wait, do we multiply?
No, because that's what I'm doing what we want.
Yeah.
I want to solve for x.
Take -3 and put it
X minus 3, set it equal to 0.
4x minus 21.
And 4x minus 21 equals 0. 4x equals 21, so x equals 21 over 4.
Oh, no,
It
we're
says
gonna
continue.
3 is hard.
Math is hard. Yeah, right.
I even see
Is there, like, tell me there's a shorter way to do this. On like the test or like quiz, you're gonna make us write all of that out.
I'm gonna make like questions.
Or like most of it.
If you get the question right, you'll probably get like 5 points.
I feel like you
Actually,
just.
this would probably be worth like 10.
Okay, that's good at least.
Okay.
That's good at least.
Well, that's a lot of work. That's definitely worth 10 points.
No, I
So
agree.
There's only
That's-
like 5 questions.
12?
12 questions. All of them like that.
No, because if it was all worth 10 points, that'd be 120 points. Okay, you're an
So, I need to check 21 over 4 and 3. Okay? So, we're going to plug them both in. Okay? So I plug 21 over 4 into the equation, and I also plug 3 into the equation. You have to do both separately. Okay? So, what's 2 times 21 over 4? Leave it as a fraction.
Okay, well, it would 46.
Which reduces to what?
What?
Okay? 21 over 4 plus 1.
No. Wait, would that be 22? No.
I don't know if you have 2 calculators.
I know, I technically could forgot. Hold on, what is it?
21 over 4 plus 1.
Oh, 1 over 4.
25 over 4.
Wait.
How do you 25?
What do you need in order to add fractions? Common denominator. So if I'm adding 21 over 4 with 1 over 1, what's my common denominator going to be?
4.
Wait, 4?
Yeah, because 4. Yeah, remember.
Okay.
Why would it not be?
That's what I
It will
thought.
be when we square root it. It actually be 5 over 2.
So what's? So how'd you get that 4 on the numerator?
I took the 1 over 1, which is 1, and I multiplied.
Oh, because you have the.
Got it. Okay. Equals 8. What's the square root of 25 over 4?
5 over 2.
5 over 2. What's 21 over 2 plus 5 over 2?
26.
What's 26 divided by 2?
13.
Does 13 equal 8?
Yes.
Said yes. What is wrong?
So, 21 over 4 is extraneous. It's not a solution. So now let's check 3.
Okay.
This one would be much easier. What's 2 times 3?
6.
What's 3 plus 1?
4.
I tried really hard not to say 4. What's the square root of 4?
2.
Does 6 plus 2 equal 8?
Yes.
So then my only solution is 3. So the solution is x equals 3.
Do you mention 24?
Nope. Don't even mention it.
Don't leave it out.
This is so not word 14.
It's a lot of time.
Noted. It's also been recorded for posterity. Alright. Step 1. Is it isolated?
Yes.
Then we're good. Step 2.
2. Square root of 2.
Square it. Okay. What is the square of the square root of 5x?
5x.
What is the square of negative 5?
25.
Negative 25.
No,
Positive,
negative
because
5.
you're adding. Okay, got it.
Negative 5 times 10. You're not adding.
I'm sorry.
Just give
This
us
is too much math.
Subtract.
What does x equal? Okay. Now what?
Check.
You check 5.
That's it.
What's 5 times 5?
25.
What's the square root of 25? Does 5 equal negative 5?
No.
That really poorly written negative 5.
So I guess so it's in
I can't.
Is there like a symbol you want us to put for that, or just
So what do I say when I don't have a solution?
there's
No
a
solution.
just 0 with it?
I like these. What was this question about the
This
test?
specifically, this question right here.
Yeah.
50-50. Probably. And here's the thing. All of this work right here is completely unnecessary.
Oh, that's fun.
oh,
I just put it into the calculator and
Nope.
why'd you say?
it's gonna give us a chance to do it now.
Yeah.
Give me a number that I can square root that gives me a negative. None.
None.
If your radical is isolated and you've got a negative constant on the other side and only a negative constant, there's nothing you can square root that's going to give you a negative. So there alone, we should be able to recognize by the property of our radicals, there is no solution. There is no value of x I can plug in that will give me any negative number. Now, if I had other stuff over here, if I had negative x, negative 5 plus x, if I had a variable over here, well, then all bets are off. We got to solve it, okay? Because then I can add something to negative 5 to make it positive. So there will be, or likely is, a value of x that will satisfy that equation. So you need to be really careful. But if your radical is truly isolated and it's set equal to a negative value, that's all the information I need to know that there is no solution. Okay? Now, if you forget that, then go ahead, solve it, take your time, go through there and see, oh, well, 5 does not equal negative 5. Okay, no solution. We'll still get to the same value, but this equation can be solved really quickly if you understand the properties of our radicals, that if I have a square root or a fourth root or a sixth root, I cannot get a negative solution unless there's something else affecting that constant. Now, let's finish up by talking about triangles. Okay? Because it fits well with our radicals and simplifying radicals, so it's a nice little thing. Okay? Pythagorean theorem. Wonderful Pythagoras. I love Pythagoras. Really smart guy. His theorem. We have a right triangle. The sum of the squares of the legs equals the square of the hypotenuse. Now, when we have right triangles, you need to be really careful in being able to determine. That's a right angle. Pretend that's a right angle. Right angle. Because that information is important. Okay? You need to be able to determine which side is the hypotenuse if it's not labeled. You won't always know the lengths of the sides. So looking at a completely unlabeled triangle, how can I tell which of these sides and which of these sides is going to be my hypotenuse? Well, if I don't know the lengths of any of the sides, how can I tell which one's the right angle is? There you go. Your largest side is always opposite your right angle. Okay? Always going to be opposite your right angle. So that'll be C, that'll be C. After you determine that, which side is A and which side is B does not matter. They're interchangeable. Okay? But C has to be correct. C has to be the longest side. Okay? So we got our Pythagorean theorem. The sum of the squares of A and B will equal the square of C. So we can use that to find unknown sides. No, it's not.
No, it's not. Because you're subtracting.
Okay? So, what am I going to use for A? I'm going to use 6 and then square it. What am I going to use for B?
14 squared.
Wait, no.
Oh.
So it's B squared. 1, because that's labeled B.
No.
But 2, my hypotenuse is 14. So that has to be C. Okay? So, 14 squared. What's 6 squared?
36.
What's 14 squared?
196.
Now what?
Subtract it. It should be 130. Oh, wait, 160.
Okay.
I said that.
That's
So
right.
that's B
But what does
squared.
B equal?
Yeah, so
Square
it's not
root
B
of that.
squared.
Well, it's just square 160. That's your answer.
It'd be like 12.65 then. Oh, so you don't need to write it.
So we need to simplify it. How can I simplify
Oh my goodness.
the square root of 160?
Wait, yes? Oh my god, I'm right.
We can get a bigger perfect square than 4.
80 and 2.
So neither of those are perfect squares.
I was guessing.
16 and what? 10. What's the square root of 16?
Can we just get a test with only that on it? Because they're really, really long ones. I'll do 2 of those questions for one of the long ones. That's fair.
Sorry. Hate to break it to you.